Hi everyone, welcome to Network Tech Zone. So far we have configured BGP using external BGP. Today in this video we will be configuring nexthop self. So first of all let us understand what is BGP. BGP is nothing but your border gateway protocol. It is used to exchange the routing information for the internet, and it is a protocol which is used between the internet service provider, which are using different autonomous system. And today we're going to learn about next hop self. So what is this next hop self? So this command will allow us to force the BGP to use a specified IP address as the next hop rather than letting the routing protocols choose the next hop. So we are manually assigning the IP address to be configured as a next hop on the router. So we will take 3 routers. The configuration is very simple. I'll just take 3 routers. So call it 3 routers here. And we will connect these 3 routers, and we'll have a different AS number because we will be using this between your EBGP and IBGP. Okay. And we will take a network here, which is 10.1.1.0/24 between iOS 2 and 3. And between these routers, we will take 20.1.1.0/24. And we will rename these routers. So I will call this as a router 1. This is going to be our router 2. And this is going to be the router 3. Okay. All right. Okay. And let's assign the IP address for R1. We will take 20.1.1.1. Of course, with the subnet mask is /24. And the IP address here, we will choose 20.1.1.2 with /24. Okay, so that's understood anyways. And between the R2 and R3, I will choose 10.1.1.1. And between R2 and R3, we got 10.1.1.0 network. So we will choose 10.1.1.2 on this router for R3. Okay. Now we will go ahead and create some autonomous systems. So I'll just draw a circle and we will divide the AS numbers. So, okay, this has become a square. Okay, let me delete this one. And we will choose a circle and I'll take a different color. take one other color here for autonomous systems. And here I will take a different color. Okay, so this router R3 that you see, this is going to be in the autonomous area AS200. Okay, and the two routers are going to be in autonomous system 100. Okay, so I'll call this autonomous system 100. Okay, this is going to be autonomous system 200. And we already know if you have two different AS numbers, okay, if that's going to be called as a external border gateway protocol, nothing but your EGP. Okay, and if you have two different routers and they're in the same AS number, that is going to be called as what? Yes, border interior border gateway protocol, IBGP. Okay, and for me to advertise some external network, I will use a loopback IP address on this AS200, and we will call this loopback 1, and we will give a name called 1.1.1.1 with /32. Okay, so now we'll go ahead and configure the IP address. I'll just start all these devices right now, and it's going to take some time. Whoever is present, you can please send a message with your name with the /BGP in the chat. Welcome, everyone. Okay, yeah, so let's go ahead and turn this devices on. I hope everybody is able to see the screen. If you can drop a message in the chat. Welcome. Okay, the devices are getting started. Okay, let's check now. Okay, it's still getting started. Hi, everyone. Let's check now. It's taking some time. Let's give it. It's still loading. Okay. All right. So there is. I would say no for initial configuration for all these devices. Okay, so now we got viOS 1 loaded. That is my R1. So I will rename this as a R1. Configure terminal, host name. I'll just increase this font size for you all to see the screen clearly. Um, okay, I hope this is visible. Yeah. Okay, so we will change this host name R1 and we will configure the IP address first on the R1 one by one. Okay, so we got interface gigabit Ethernet 0/0 IP address 20.1.1.1 with /24 for the subnet mask. Okay, and no shut. All right, now we will move to R2 and configure the IP address. Let's change the screen font size for this CLI. Okay, we are in viOS 2, which is nothing but your R2. So let's rename this. Configure terminal, host name R2. So here we got two interface. We need to assign the IP address for two interface. So let's go ahead and assign the IP address. IP address interface gigabit port. We got 0/0 and we'll give us IP address here, IP address 20.1.1.2 with /24 for the subnet mask. Okay, and no shut. So this is done for the 20 series. Now we got one more interface for 10 series. So that's on gigabit 0/1. So we will give the interface command gigabit 0/1 and the IP address is 10.1.1.1 with /24 for the subnet mask. Okay, and no shut. And we'll go to R3, increase the font size, and we'll change the appearance here to make sure that it looks clear. and we will give the name enable configure terminal host name, and host name is R3. uh, and the IP address you see here is for the port, which is gigabit Ethernet 0/0. So interface gigabit Ethernet 0/0, and IP address we got is 10.1.1.2 with /24 for the subnet mask. Okay, and no shut. Now we will go ahead and check whether you're able to reach R1 and R3 from R2. Okay, that is, I'm going to try, I'll try to reach R3 and R1 from the router R2. Okay, now we will go to R2. This is just to make sure that our IP address configuration is all right. So ping my neighbor IP address, which is 20.1.1.1. That's connected. Okay, and let's check the other side to reach R3. So ping 10.1.1.3. Okay, there's some problem with the IP address. It's not pinging. Let's check show run. I guess we did not give the no shut command. Welcome. Let's just make sure that we will turn this interface on. So we got interface gigabit 0/1, no shut. We'll give the no shut on this R3 as well. It's already no shut here. Let's try to ping from 10.1.1. So we are on R3. So my next IP address is 10.1.1.1. Let's check. Yeah. Okay, that's working. From R2, let's check. Ping 10.1.1.2, which is my R3, the neighbors. So there is connectivity. So now that it says that our IP address is configurations are right. So at the moment, I have not configured any BGP. So we will go ahead and configure the BGP. So first we will start with the AS200 and we will configure the BGP on R3. So configure terminal, router, BGP 200. So because we are in the AS200 here, right? So it's router, BGP 200, and our neighbor. So who is the neighbor for R3? Can you type in the chat box? Who is the neighbor for R3? For R3? It is 10.1.1.1. So neighbor 10.1.1.1, and your remote AS. Remote AS is nothing but your uh, neighbor's AS number, nothing but the AS 100. So that is going to be my AS number. So, okay, so that's the command for BGP. Let us now move to configure the BGP for the IBGP between R1 and R2. So I'll start with R1. Okay, on R1, configure terminal router BGP, and BGP is 100, and neighbor we got here is for R1, the neighbor is 20.1.1.2. So I will just take the same thing, 20.1.1.2 with the remote AS. So what is my remote AS if I am configuring BGP on R1? My remote AS is going to be by neighbor's AS number, which is obviously AS 100 itself, because this is an internal BGP. It is between the same AS number. So remote AS is going to be 100 itself. Okay. So that's on the R1 because this is IBGP. Now we will go to the R2. R2, we are on R2 router. Let's configure the BGP, configure terminal, router, BGP, and here R2 is obviously in AS 100, correct? So I will take router BGP 100. Okay, and I have got two neighbors. So one neighbor is the R1, okay, and the other neighbor is my R3. So let's configure the same. So neighbor 20.1.1.1, okay, and my remote AS towards 20 series is going to be AS is 100, right? Autonomous system is 100, and then I have one more neighbor, that is my 10 series, and my neighbor is 10.1.1.2. So you can see adjacencies are happening. So neighbor 10.1.1.2 with the remote AS number. Remote AS. This remote AS for 10 series. The 10 series is a part of autonomous 200. So hence I will take remote AS 200. Okay. So that's your BGP configuration on R2. You will see that there is going to be a formation of the BGP adjacency. You can see here BGP adjacency has been formed for the neighbor, and the neighbor is up. Okay, so now we will run a command to see the BGP summary. Show IP BGP summary. You are seeing your neighbor. I'm on the R1. So this is my R1, and you are seeing 20.1.1.2, which is nothing but your neighbor. And AS number is 100 because your R1 is an AS number 100. Okay, and prefix is 0 because you have not advertised any network. Okay, yeah, and it's up from past 52 seconds. It's up from past 52 seconds. Similarly, if you want to check R2, I'm on R2. Check for neighbors. Show IP BGP summary. You will see two neighbors because we got two neighbors connected. One is R1 and one more is R3. 1020 series and 10 series. That's what you see. And you are seeing 0 for the prefix because we did not advertise any network. And you can see they're up. The neighbors are up the adjacencies are up from past 58 seconds and from 1 minute 31 seconds. Okay, and similarly on R3, if you want to verify, you can check show IP BGP summary. It's up from past 1 minute 36 seconds, and your neighbor is 10.1.1.1 because I'm an R3. So for R3, 10.1.1.1 is my neighbor. So now we just got the IP address configured and we got the BGP configured between the EBGP and the IBGPs have, but how do we connect the loopback IP address, right? So we already, I hope we have already configured the interface for the loopback. I'll just say show run just to make sure we have the configuration for the loopback. Or just you can use the command show IP interface brief. So you don't have configuration for our loopback yet. So we will go ahead and configure the loopback IP address. Okay. All right. Let's configure the loopback on the router 3. Configure terminal, interface, loopback. And loopback is one IP address. Need to specify IP address here. IP address is 1.1.1.1 and it is /32 for the subnet mask, and hence we will take 255, 255, 255 and 255. Okay, so this is, we just configured the loopback IP address. Now if you are trying to ping from any of the routers, you will not be able to reach the loopback IP address because it's a different subnet. So if you want to try to reach from R2, so it will fail. So if you can check ping 1.1.1.1, it's going to fail because you don't have the routing protocol configured. You did not advertise it. I'm sorry, you have the routing protocol for BGP configured, but you don't have the network advertised in your BGP, and hence it will not work. So let's go ahead and advertise this loopback in the router BGP for this R3. So let's go to R3 and configure terminal. Okay, and router BGP, and here the AS number is what? AS 200, right? So router BGP 200, and we will advertise the network. So network 1.1.1.1.1. I'll take the entire IP address and I'll take the subnet mask, the entire 32. Okay. So that's all. And now you can see it is configured from console by console. Okay. So from R3, if I want to reach from this local router itself, I'm trying to reach this 1.1.1. Let's see if that's working. That's working. And from R2, let's see if I'm able to reach this IP address. Ping 1.1.1.1. That's working as well. Let's go from R1. Ping 1.1.1.1. It's going to fail. It's going to fail. Why? The reason why you are not able to ping from R1, you're not able to reach loopback IP address from your R1 because you have not advertised your network between from on your R2, because R2 is separating the two different AS number and it's connected between two different network. So first method is you can advertise both this network, that is this 20 and third and the 10. The second method is you can go ahead and configure next hop self on the R2. So this is the main router in which you will be configuring next hop self. It's second method, and we will see what happens when you advertise just this network, okay? And see how it's going to work. Let's go ahead and advertise this 20 and 10 network in the R2 and see the difference. We will go to R2, configure terminal, and router. This router is going to have AS area autonomous system is 100, right? R2 is an autonomous system 100. So it's router BGP 100. Okay. And we are trying to advertise these two network, 20 network and 10 network. So let's go ahead and advertise that network. So network. So let me just scroll this down the other side so you can have it look clearly. So we are on R2 and our network is 20.1.1.0 that you see here. So let's advertise it 20.1.1.0 with the mask, and we said it is /24 here. So hence 255.255.255.0. Okay. We still need to advertise 10 series network, right? Because R2 is connected to two networks. So let's go to R2 and advertise 10.1.1.0 mask. And of course it's /24. So 255.255.255.0. So we have just advertised both the network. Now let's try to ping from R2. It's going to take some time for the packets to exchange, but that's okay. So ping, we are on R2 and we'll try to reach this IP address first, 10.1.1.2. Let's go hop by hop. 10.1.1.2. So that's working. Then we'll try to go ping 1.1.1.1. That's also working. Let's go to R1, this router here. Earlier it was not pinging. Now because we did not have network advertised. So if you want to advertise it, and let's see if this is going to work now. See? After we advertise your 10 and 20 network, you have got reachability. You can reach your loopback IP address. But how did the packet go? If you want to understand how the packet has gone and which route it has taken, let's say show IP route. Let's check the routing table to see what is the flow of the packets. So show IP route. Do you see this is called B stands for the BGP, and they are going to be externally connected. So 10.1.1.1 is something which the R1 don't know because it's in a different area. I mean, I'm sorry, it's in a different autonomous system and a different subnet, right? And then this BGP is connected to 10 here because this is something which is not directly connected. So it is aware of 10 series and aware of 1 series. So that's the reason why it's BGP. And you see here 200. What is this 200 standing for? 200 stands for administrative distance for external BGP. Okay, but it's reaching 1.1.1.1 via 10.1.1.2. Just look at this. This router R1 is connected via 10.1.1.1, and from here it's connected to loopback. That means this R1 is totally bypassing your R2. Okay, but R2 is going to instruct R1 saying, hey, Mr. R1, you need to pass via my IP address. In order to reach, I'm going to take a different color. Okay, some different. So this R2 is going to say, R1, you have to reach my IP address first, which is 20.1.1.2, and then reach this IP address if you want to reach my loopback IP address. Sorry, another loopback IP address present in the autonomous system 200. So that's how you can configure the next hop self on your router. So r- instead of directly connected to this R3 to reach loopback, it's going to use the router to IP address first. Okay, and then it will go to your loopback. So let's go ahead and remove this. We don't like this network advertisement because it's not going via R2. It's directly bypassing your R2 and then moving to R3. So I'm going to remove this no network command just to make sure. Okay, this is what you got before, right? I'll just make a note to make sure that you see the differences. So this is what you got earlier, where you did not configure next hop self. It has gone via 10.1.1.2. Now I will just remove those network advertisement which we did on R2. So on R2, if you say show run, see here, we got two network. I will remove this. I don't want this router to go and bypass R2 and directly reach R3. So I'll remove this. Configure terminal. Router BGP 100. I'll keep it the way it was earlier. No. And keep a no command and remove that other neighbor also. If I remove, obviously it will not work. Again, there will be a failure, correct? From R1, you won't be able to reach that, we know. Now, instead of using these two commands, you can just use one command. Let's check that. Configure terminal, router, BGP 100. Okay, because your R2 is an autonomous system 100. And use only one single command, which is neighbor. Okay, what's my neighbor for R2? My neighbor is 20.1.1.1. Okay, so I will use neighbor 20.1.1.1, right? And use next hop self. That's it. Only one command. This is the only one command that we have used on the R2. I'll just post that here. Okay, I have removed those network and just added single command here. And this is something which we got when we advertised the directly connected network on the R2. Now let's see how the routing table looks like. Control Z. I'll just save this. And it's going to take some while for the packets to communicate between the routers. And I'll go to R2 and ping 1.1.1.1. Definitely it will work. Now we will try to ping from R1 and see the results. Ping 1.1.1.1. Okay, it took a while. Do you see here the BGP? Now it is via 20.1.1.2. This was earlier, and now the same IP address is now reachable from 20.1.1.2, which is nothing but this IP address. So 1.1.1 is reachable from your R1 via 20.1.1.2, and then it's going to the loopback. Okay, so this is how you can configure next hop self on your router. And if you want to verify, show IP BGP. Do you see here your network? To reach this valid network, it has gone to 20.1.1.2, your next hop. It's no more bypassing your R2. Okay, it's 20.1.1.2, and that's there. You can still reach. Okay, so the only difference is that if you configure the next hop, you're telling the router R1 that you will be following this IP address which is configured by your R2. So I hope that this video has been informative to everyone. I see you in the next video. Thank you so much for joining.